Hi, students. In this lecture, I am going to discuss problems based on torque hinge reaction. Let us see first one. Let's see the question given. A thin and uniform rod of mass m and length L is held vertical on a floor with large friction. The rod is released from rest so that it falls by rotating about its contact point with the floor without slipping. Which of the following statements are correct when the rod makes an angle of an angle of 60 with vertical? Okay. So asked in 2019 advance and say options. So we have to find angular speed, radial acceleration, normal reaction from the floor, and angular acceleration of the rod. So we have to find omega, alpha, acceleration along the radius, right? Let us see how to start the problem. Condition is that thin uniform rod held vertical. So when angle becomes 60. So first make the diagram for given data. Initially rod was vertical. Rod was vertical, placed on a horizontal ground, which is a rough. After some time, this rod makes an angle 60 with vertical. Angle is now 60. So when it makes angle 60, we have to find omega value. Next alpha. And next we have to find out normal reaction from ground. Normal reaction from ground. Next, acceleration along the radius known as radial acceleration, or you can say centripetal acceleration. So these things we have to calculate. Let us see how to start. See, to find omega, we can use conservation of mechanical energy, right? Since no slipping here, there is no energy loss. So when this is rotating, center of mass follows now circular path, right? Center of mass follows now circular path. See once. Center of the rod will be center of mass, and that follows now circular path of radius L by 2. That means center of mass is coming down. Okay. So losing gravitational potential energy, and this loss in gravitational potential energy converts into kinetic energy because of rotation. See what we can write. If you are taking now ground as reference level, initially height was L by 2, right? Now height is, it is L by 2 cos 60. Initial height L by 2, present height L by 2 cos 60. That means it is L by 4. See how much height it has come down. It is L by 2 minus L by 4. It is L by 4. So loss in the gravitational potential energy, that is mg L by 4. Okay. This is loss because L by 2 minus L by 4. Okay. So mg L by 4. This is a converting into kinetic energy because of rotation. That is equal to half I omega square. I value ml square by 3. Rotation about one end of the rod. Half I omega square. M, L, M, L gets cancelled. And 2 here, 2 times. Remaining is now. See from this omega square, how much? It is 3g by 2l, right? 3g by 2l. So first option is root of 3g by 12. So that is matching, right? Next. See, next what we have to calculate. We have to calculate alpha. If you want to find alpha, we have to focus what is net torque. Okay. And again, we calculate torque about the bottom end. Okay. Because rotation is about the bottom end of the rod. So when you take about this end of the rod, because of hinge reaction, there is no torque. Torque is only because of gravitational force. Gravitational force mg vertically downwards. See, torque is now mg into distance. Distance equal to, it is L by 2. L by 2. This is now distance, okay? L by 2 sine 60. So L by 2 sine 60. Sine 60 root 3 by 2. This torque equal to I into alpha. And I value ml square by 3 into alpha. M, L, M, L gets cancelled. Alpha equal to 3 root 3, 3 root 3 G upon 4L, right? That is alpha value. That means option D. It is not correct. Next. Next, what we have to find out? Acceleration along the radius, right? Acceleration along the radius means if you multiply that with the mass, we are going to get centripetal force, right? That means is centripetal force, or you can say acceleration along the radius means centripetal acceleration, which is equal to r omega square. Here r means L by 2 omega square, right? So L by 2 in the place of omega square 3g by 2l. 2 gets cancelled. It is now 3g by 4. That means option B is matching. Okay. So we got now omega value and AC value alpha, right? Omega is over, alpha is over, AC is over. We want normal reaction from ground. Okay. Then say how to find normal reaction from ground. So you can see here mg vertically downwards. Normal reaction from ground, it is vertically upwards. Then we can write mg minus normal reaction from ground. This is net force, which is equal to mass into acceleration along vertical, right? It is acceleration along vertical. Then see how to find acceleration along vertical. So I'm making diagram once again here. Initially it was vertical. Now this is making an angle 60 with vertical, and this has acceleration two components. Acceleration of center of mass. It has two components. One is towards the center, that is AC, and one is along the tangent. Okay, this is AT and this is AC. And we want acceleration along vertical. Along vertical means we have to take components for these two. Okay. Focus now. Components along vertical. This is 60. Then this also 60. So AC cos 60. It is now AC cos 60. And a component of 80. This is 60 means this is now 30 plus 80 cos 30. Okay. So now we got acceleration along vertical. So mg, known value. We want to find out normal reaction from ground. AC, that is known. And what about AT value? AT equal to R into alpha. AT value R into alpha. R value L by 2, right? L by 2. Alpha is now 3 root 3G by 4L. Substitute that here. 3 root 3G by 4L. Okay. So AC is known, substitute here, and AT is known, substitute here, and we have to make calculation. Then we are going to get normal reaction from ground, that is mg upon 16. Okay. That means that given option. So what's the given options here? Option A, it is correct. Option B also correct. Option C correct. Option D is not correct. Because we got alpha value how much? 3 root 3 G by 4L. Okay. Let us see next problem. Let's see the question given. A uniform rod pivoted at its upper end, hands vertically. It is displaced through an angle of 60 degree and then released. Find the magnitude of the force acting on a particle of mass dm at the tip of the rod when the rod makes an angle of 37 degree with the vertical. Okay. Let us see how to solve it. So first make the diagram. Uniform rod fixing at the upper end. This is a rod fixing at the upper end. Now this is a displaced through an angle 60 and released, right? So now we have to find. So when the rod makes an angle of 37 with the vertical, we have to find force acting on the particle. So when this makes an angle 37, when this makes an angle 37, we have to find the force. There is now one point mass given as dm, right? Fixed at the other end. There is one point mass here, that is a dm. Its meaning is this mass is very small when compared to mass of the rod. Okay, let us see. If you observe this point mass, this is a following now circular path. When rod is rotating, this point mass follows now circular path. So when this follows circular path, we have to focus who is providing now centripetal force. At the same time, while moving like this, omega of the rod keep on changes, right? That means it is also having force along the tangent. Okay. That means first of all, we have to focus what is omega value. Now see carefully. Again, to find omega value, we are going to use conservation of mechanical energy. See how much distance the center of mass is coming down. Okay. Center of mass comes down. That is given by so loss in the gravitational potential energy. If m is mass of the rod, mg, mg, or we can take L by 2 also outside, L by 2 outside. Remaining is now cos 37 minus cos 60. That means L by 2 into cos 37 minus cos 60. That gives by what distance center of mass has come down. So mg into h. This is loss in the gravitational potential energy, and this loss converts into kinetic energy because of rotation. Half I omega square, I value, ml square by 3. Half I omega square, right? So L, half, half, L gets cancelled. Remaining is now, this is 4 by 5, right? Let us calculate once. 3 here, take here. 3g by 3g by L, right? Remaining part 4 by 5 minus 1 by 2. That is now omega square. Okay. Next, coming to here on this one. One is centripetal force. Other one is tangential. Resultant of these two is the force by the rod on the particle. To find Fc, we require Fc equal to mass dm. It follows circular path of radius L. See carefully, we are focusing this point mass dm, and this dm is following now circular path of radius L. Okay, so m r omega square. What is omega square here? 4 to 8. 8 minus 5, 3. 3, 3 is 9, right? 9 by 10. That means 9g by 10 L. L gets cancelled. It is now 9 dm into g by 10. That is now centripetal force. Now we have to get tangential force. And tangential force is given by, it is equal to m into, that is a dm into r alpha, L into alpha. So to find alpha value, we have to take now torque equation. We have to take torque equation. Now focus here about this fixed point. Okay, when you are taking torque equation, when compared to mass of the rod, mass of the particle is very small. So taking torque due to only weight of the rod, that is mg into L by 2 into, when angle is 37, right? Torque is L by 2 into sine 37, right? It is sine 37. Sine 37 means 3 by 5. Okay. Let me cross check once. Mg into L by 2 sine 37. Okay. Sine 37 is 3 by 5. That is equal to I into alpha. I value ml square by 3 into alpha. M gets cancelled. L gets cancelled. So alpha equal to 9g by 10 or 10L. Okay. That means now tangential force is, if you take L alpha, I'm taking L here. So L alpha, that is equal to 9g by 10. That means this is again same as epsilon, right? 9 dm g by 10. So tangential force and centripetal force, both values are same. And between these two angles is now 90. The force by the rod on the particle is resultant of this two. That is now root 2 into 9 by 10 dm into g. Okay. So you can observe that in all these problems, we have taken one is energy conservation, that law of conservation of mechanical energy. From there, we are getting omega square value. Next, by using torque equation, we are getting alpha value. And once alpha is known, we are getting tangential acceleration. Once it is known, we can find force. Okay. Let us see next one. Let's see the question given. Consider a body of mass 1 kg at rest at the origin at time t equal to 0. A force F bar equal to alpha t I cap plus beta j cap is applied on the body given alpha, beta, both values 1, 1. The torque acting on the body about the origin at time t equal to 1 second is tau bar. Which of the following statements are true? So asked in advanced 2018. See options given. Torque, direction of torque, velocity, and magnitude of displacement. Let us see how to solve it. F bar equal to, given alpha is 1, beta is 1. So I'm taking directly Ti cap, Ti cap plus beta also 1, simply J cap. This is now force. So we have to find out torque, right? Torque means R bar cross F bar. Okay, means we require R bar, right? And velocity also we require. You can see options given. Torque, direction of torque, velocity, displacement. Then we can do one thing. So here, first of all, we can find, since mass given 1 kg, acceleration equal to, acceleration is dv bar by dt. That is equal to Ti cap plus j cap, because mass is 1 kg. See from this what is velocity? dv bar is equal to Ti cap plus j cap into dt. Now integrate 0 to t, 0 to v bar. Okay. Because condition given that it was at rest at origin at t equal to 0. So v bar equal to t square by 2 I cap plus t j cap. Okay. Next, we want displacement also, right? So this can be taken as dr bar by dt. Dr bar by dt, that value. Then dr bar is equal to t square by 2 I cap plus t j cap into dt. Okay. Now integrate. So initially it was at origin, right? So t equal to 0. It was at origin. At time t, it is r bar. So r bar equal to t square dt becomes t cube, right? T cube by 3. So t cube by 6 I cap plus t square by 2 j cap. So first we can verify which options. Let us see. First we can verify option C. Okay. Velocity when t equal 1 second. T equal 1 second, 1 by 2 I cap plus 1 j cap. So it is matching, right? 1 by 2 I cap plus 1 j cap. T equal to 1 second. So option C is correct. Coming to D, magnitude of displacement. When you take t equal to 1 second, it becomes now r bar. When t equal to 1 second, 1 by 6 I cap plus 1 by 2 j cap. So modulus value how much? Square root of 1 by 36 plus 1 by 4. So option 4 is not correct one. Option C is correct. Now focus on torque. So directly we can say torque equal to R bar cross F bar, right? Definition of torque, R bar cross F bar. Now see R bar cross F bar, I cap, J cap, only two. R bar. R bar is now when t equal to 1 second, right? 1 second means it is 1 by 6 and this is 1 by 2. And coming to force, 1 second means this is 1 and this also 1, right? Then see what we get. 1 by 6 into 1. 1 by 6 minus 1 by 2, 1 by 2 into 1. It is 1 by 2. So into direction k cap, right? So 2 minus 6 minus 4. Minus 4 by 12 k cap. That means it is a minus 1 by 3 k cap. Magnitude is 1 by 3. Direction is minus k cap. So magnitude is matched, right? So option A is correct. Coming to B, given plus k cap, that is wrong. Okay. So very simple and direct question.